Sadly, I didn't get all that on record, but here we go. The derivative is a function. So the derivative of a function at A is a number, f prime at A. You substitute A in, and you find the slope of the tangent line to the curve at this point. But if we let A vary over the domain of the function, we can change our point of view and regard f prime as a function in itself. So given a function f, the derivative of f is called the function f prime. We define it this way: f prime at x, limit as h goes to 0, f at x plus h minus f at x all over h. Okay, so find the derivative of f at x equals x squared. Well, what's my definition for the derivative? F prime at x is equal to the limit as h approaches 0 of the function at x plus h, at x plus h, got to compose that, minus the function at x all over h. Have you seen this before? Yeah. Only difference is we put an a in here, and we substituted the value in. Now we're putting a variable in here and finding a function. Okay, so what is the function at x plus h? Well, this will be the limit as h approaches 0. Well, the function at x is x squared. The function at x plus h is x plus h squared, minus the function at x, which is x squared, all over h. What should I do with that? Expand, collect like terms, and hope to cancel the h out of it. So I've got limit as h goes to 0, x plus h all squared gives me x squared plus 2xh plus h squared, subtract x squared all over h. And positive and negative are going to cancel each other out, and I get the limit as h approaches 0. And I've got 2xh plus h squared. Can we see that the remaining terms both have a factor of h? And I'm going to factor the h out of it. And then those cancel. And if I evaluate this by direct substitution, what happens if h goes to 0? I just get 2x. What's 2x? The slope of the tangent line to this curve at any point x. So if you think of what that looks like, it's a parabola, and we did a lot of these in Math 11. It opens up with a vertex at 0, 0. And if I ask you what's the slope at 0, let x equal 0. What's the slope? 0, isn't it? It's a horizontal line. What's the slope at 1? If x is 1, what would the slope be? 2. Kind of looks like that. And what would happen if x gets bigger and bigger is my slope keeps getting steeper and steeper. And if I were at this point at -1, what would the slope be? -2. Doesn't it look like it? So that's what that's giving you. Okay? So here's a second example. If f at x is root x plus 2, find f prime at x. And one more thing, because this is a radical function not defined for all reals, we're going to also have to state the domain of the function and the domain of the derivative. Okay, so I'd like you to start off by writing down the definition for f prime at x, and then try substituting it into the equation you've been given. So go ahead and do that.